Alright, now we are going to do Banggood Item 1183896. It is their FM transmitter wireless microphone MP3 repeater with antenna. We will get started here in just a second. Bringing everything up. Alright. Using 2 Ziploc bags, which I guess is good because then you don't lose any components. Alright, we got a circuit board, which looks pretty good. It's only single-sided, but I guess that's all it needs to be. We've got a microphone, an audio jack, an antenna wire. We got a adjustable capacitor. Got a that might be the one that goes there. But I've got a couple of air coil inductors. Screw terminal. I got an electrolytic capacitor. So that one's going to need polarity. Let's see, I got 101, 101, 101, 102, 102, 15. 68. These I'm assuming are 8 turns. We'll count them in a second. That's a 5 turn. So 1, 2, 1, 8, 15, 104. 30s. LED. Probably another 104. Yep. Another 104. I don't know how much I'm going to use the instructions on this. That's another 30. These all 9018s? No, one of them's a 9014. It's a 9018. There should be another 9018. Yep. And a bunch of different resistors. And an LED. Okay. Hopefully we got all the pieces and parts and things. Well, I'm at it. Oh, fire that up. Okay, for those wondering, I was just setting something up on the other screen. Up. So, when it comes down to this, I'll be able to test it with my software-defined radio. Oh, come on, Workbench Cam, come back. So that works. There we go. That's so weird. All three of those cams are on the same encoder because they're analog cameras that I'm encoding to digital to get them into the computer. So if one works, they should all work, but it doesn't work that way sometimes. It's weird. Okay. So, we got resistors. I'm too lazy to read resistor color codes, so I'm just going to use a voltmeter. Move that in there. I don't think this thing has a backlight. I don't know if you can see that. Okay, good. Yeah, you can see it. So we got... Uh, 99.4. I'll call that 100K. So where's my 100K resistor go? It goes in R4. Now, since this board's a single-sided load, you don't have to worry about it sucking through the solder like you did on the last one, because there's nothing for it to have to worry to bridge up here on the other side. Orange, there's going to be have 7 in it somewhere. Or no, orange is 2. 21K? No, I'll say 22K. Goes in resistor 8. Purples and yellows. This, I believe, is going to be a 4 or 7 something. That's going to be 470 ohms. So that is in resistor 9's slot. Brown, black, brown. Should be a 1K, I believe. Yeah, 1K. And again, I could sit here and read color codes and decode them, but I'm being lazy. Where's my 1K go? Or is this 100 ohm? My bad, sorry. This is a 100 ohm resistor. So that goes in resistor 3 slot. Which means these two resistors here are probably my 47K. Close enough. And that would make these the 10K resistors. Yep. Okay, and the 47K goes in R5 and R6. Rest are 10K, which is going to be R1, R2, R7, R10, and R11. Well, Mr. Wells, my going rate as an electrician is $35 an hour. Just so you know. And believe me, I think that's a cheap rate. I think that's an apprentice rate. Oh, and since you're out of state, you pay all my expenses such as hotel, food, and gas, so. See, now, Lady G, I might take up that offer of the couch and your home-cooked meals before I take up Mr. Wells and his cooking. We probably don't need you anymore. Oh, and for those of you wondering on the new meter, that was actually my grandfather's. It was left to me when he passed away. So that's one of the things I got to bring home. It's well used. The range switch is just about worn out, but it still works. Alright, all the resistors are in. Time to get my solder. Tap down one leg of them. I'd have to convince the wife to let me go to, and work to let me go to Pennsylvania, or is it Pennsylvania or is it New York? For like a week. Okay, all of those look good, so it's time to solder the other leg down. I think the big one, though, would be convincing work that I needed the time off. Oh, and I'd also have to read up on your local codes too, Lady G. Because some states require me to be part of the union to do residential homes as well. Here in Arizona, it's only commercial buildings that require you to be union. But I know, like New York State, for example, yeah, I would have to be union even for a residential home. Otherwise, the local electricians union could file a grievance against me and land me in court. Oh, so it's like my house where if you run the microwave and the dishwasher at the same time and then the fridge kicks in, it kills the entire kitchen except for the stove. So yeah, if you're running the dishwasher, you can't run the microwave in our kitchen. Because if the fridge kicks in while that's happening, pop goes the circuit breaker. Even though, oddly enough, the fridge is on its own breaker. Still haven't figured it out. Well, I know my dishwasher and my microwave are on the same circuit because this house didn't originally have a dishwasher, and they literally just tapped off the outlets in the kitchen to put the dishwasher in. But why it pops the breaker when the fridge kicks in, even though the fridge is on a separate breaker, don't know. I didn't do very good solder joints on those. They'll do though. Alright. All my resistors are in. What does it recommend next? All the capacitors. Okay. Alright, so I've got a 104, which goes in C2. I got a 104, which goes in C5. Now, I originally bought this kit because I was having trouble with the aux input on my car, my company car. So I bought this to, be a transmitter for my podcasts. But then I found out that it doesn't transmit on standard FM frequencies. It transmits on... ...88 to 108. Well, actually, no, that is within the right frequencies. So I have to try to set this to 88 megahertz when I go to program, or when I go to test it. It would be under your state's rules and regulations to whether it requires union labor or not. Pennsylvania, I don't think is, but I could be wrong. I just know New York is, because everything has to be union in New York. Okay, 102s are in. Let's do the 101s now. That isn't entirely correct, Mr. Wells. They still have to follow federal building codes. They just don't have additional building codes on top of that. And give me a sec. So, you have the NFP72. This is everything about fire alarm and signaling. This is a national code that everybody in the United States has to follow this. You've got the IBC. This is the International Building Code. This is a coalition between the United States and the European Union. This is building code standards that both countries have chosen to follow on a federal level. And you have the NFP 70. This is the National Electric Code of how everything has to be done electrically in the United States, Mr. Wells. And they're not thin books. You know. And as a fire alarm tech, I have to know everything that's tabbed. I have to know all of that stuff as a fire alarm tech. So yes, national building codes are a thing. Now, most of those things are general, they're general codes. They're, you know, like for a circuit that has X amount of amps and X amount of volts going through it, the gauge of wire should be this, you know. Like for example, a 20 amp breaker on a 120 volt circuit needs to have a minimum of a 12 gauge wire. Okay, yeah, Spoon, I understand EU isn't a country, but I'm saying the coalition of the EU has agreed, stating these are general building codes that we will follow. Now, I know over there in Europe, I think they have gone further than that book in most countries. But that's like the baseline. I don't know if the EFTA or EEA member states are part of that as well. I just know that some governing agencies in both Europe and here have said this is how we should build things. But like I said, it's general stuff. It's not a end all be all code. It's a, you know, like some of the stuff in there is lighting should be spaced every so many meters or feet to properly light up an area. In the case of fire alarms, you have to have notification appliances spaced no more than 15 feet apart. Or wait, no. What is it? For every 4 foot by 4 foot cube, you have to have at least one 15 candela notification strobe light. I forget what that equates in meters. I think it's a one. I think the book actually says that it's a 1 meter by 1 meter cube. I can't remember I'd have to look it up. But yeah, then most states have additional codes beyond that, and just all fell out and went all over the place. Now, granted, here in Arizona, we pretty much follow the NFPA ruling on our building codes. The only difference is we have a few things that we do a little differently, which is actually still covered under the NFPA ruling, because the NFPA ruling, their ultimate end-all be-all is the authority having jurisdiction has the final say on the building code. So your local fire marshal or your local state inspector has the final say as to whether something meets code or not. And you do not argue with your local fire marshal. I've seen people do it. And it never ends good for them. because you start arguing with the fire marshal, he will find everything wrong with your fire alarm system from that point forward. And he will ding you on everything. Like, I had a coworker one time start arguing with the fire marshal over something. And he ultimately failed us because we had the wrong color wire. All because my coworker decided to argue with him. So he had to pull every scrap of wire out and replace it. You'd be surprised, Mr. Wells. Overload a circuit and... yeah, you've got a fire on your hands. Yeah, don't believe us that an electrical fire can happen, Mr. Wells? Look up arc flash on YouTube. Okay, I think all my capacitors are in nicely. I'm going to trim the leads. Took a little bit to get those ones to go in, cooperate and go in nicely. They kept wanting to slip out. I'm beginning to like surface mount more and more these days. Less cleanup. And less hassle. I don't know what they call that one in Germany, but here in the US they call it Billy Goat's Gruff, I believe, where it was the 3 goats crossing the bridge with the troll. I can't remember how the fairy tale goes. I know it was originally one of Grimm's fairy tales. I just can't remember which one. Alright, those are in. Now it says to do this electrolytic next, with the negative towards that side. But how tall is that going to be? Yeah, it's fairly short. I'll work around it. You may be right. I mean, it's been a while since I've read fairy tales. Okay, so we got the electrolytic in. What does it recommend next? I'm thinking it's the coil. Nope, it's the transistors. It recommends the transistors next. Okay. Again, I'm doing this little kick bend thing on them. It's hard to see it, but this one is the 9014, so that goes in Q1. And in hindsight, They space the holes close enough together that I don't need to do that kick bend thing. Okay. Should have looked at that before I bent those. Okay, the 904 goes there. And 9018 goes here. Let me just double check that out for 9018. It is. I'm sure one of these is a PNP, the other is an NPN, and I just don't want to look it up right now at the moment. There we go. The transistors are in. We will solder the collector, also known as the center pin. Of course. Alright, they all look good, so tack down the other 2 legs on each. Yeah. I just caught an audio wire. Oh. It says to do the inductors next. Which, yeah, we'll do the inductors next. So the 5-turn one goes up here in L3. And then I've got 2 8-turn ones that go in L1 and L2. And these are just air-wound inductors, and I should have put those in sooner because they're, yeah. See, I should have just measured instead of going with what the sheet says. Okay, none of them want to stay in, so fine, I will. That one in. Take that one in. Now, note to self, kids: do not do what I am doing right now unless you have pretty decent calluses on your fingers. Or wearing heat-resistant gloves. Because this is literally a bare metal coil. Well, it's a conformally coated metal coil. So it's electrically insulated. You little bastard. But it is not thermally insulated. So all the heat I'm putting on it is going right through to my finger. Okay, they're all in. So we'll tack the other side down. Connections to make sure they're nice. Alright. All the coils are in. I think the 7-turn one is taller than my audio jack. Yeah, audio jack should be next. No, I completely forgot about the LED. We'll have to get the LED in there too. Audio jack is in. Bridge between the two, and I'm out of shot again. There we go. Both of those. So I had my soldering, I thought I could cheat. I put my soldering iron between the two pins and thought I could do them both at the same time. But it bridged the two pins together, and then I had to clean it up. So it didn't save me any time. Okay, audio jack is in. Which is taller, okay. On a microphone, the negative is always connected to the outer housing, so you got to look at the bottom and see which one's connected to the outer housing. Microphone is in. Let me just see about getting that LED in. As I drop it on the floor. Ow. Uh-oh, what did I just step on about down here? I just stepped on a chunk of plastic that blends in with the color of my carpet. That kind of hurt. There we go. Again, just like everything else, we solder the one leg. Oh, that smelled good. A piece of my hair got stuck in that. It's stuck on the end of my soldering iron. Yeah, lovely. Burnt hair. Okay. LED is soldered in. And the 7-turn variable inductor, or I forgot to make sure it was flat. Yeah, it was flat. Okay. And then the power input is my final soldering. Oh, nope, I got the antenna still. And last but not least is the antenna. Ideally, once you get this set for a frequency, you'd trim it to the right length, but I don't care to do the math at the moment. I can do it later. Okay, there we go. Steal the audio coming from my sound system. I'll unplug all that stuff for now. I need a 5-volt power source. Okay, since we are done here, I am going to flip over to the other screen. And we are going to see if I can get audio to come out of this. I need to flip tips. And some wires are in the way again. Sucked into a cooling fan that I have over there. My audio gear gets warm, so I have a computer fan blowing on it, and that scrap of whatever that was just got sucked into it. I really need to clean off my desk again. Okay, so what you're looking at is you're looking at my software-defined radio that I bought a while back on Amazon. I have it tuned to roughly 88 megahertz right now. This is supposed to transmit around that frequency. So what we'll do is I will fire this up and see where it ends up on this frequency. Okay, we'll hook the ground up first. Hook that up. Alright, now we will scan to see where the audio is going. Alright, so I will pause. I will turn up the volume slightly on this. Nope, that's a local radio station. That's a local radio station. Ah, this is probably it right there. So if we kill the computer... Oh. Yeah. Hey. There I am. We are tuned to 93.1 megahertz right now. Interesting little echo. Oh, it is a dirty, dirty transmitter. That is a dirty transmitter. So, you see this right here. This is a typical FM broadcast radio station. It is about, the frequency is about 200 kilohertz. I am throwing up stuff all the way out almost a megahertz either side. Oh, and I am stepping over a frequency right now. Let's see if I can tune this thing. Okay, you're wrong way. I don't know if I have a radio voice, Spoon. But this is Radio Brute Cloud. It's kind of cool. I actually built an FM transmitter. Now I just need... Well, it's a dirty FM transmitter, so... But I'm transmitting at... Wow. wow, 20 dB, negative 20 dB. That is a hot and dirty signal. Oh, when are you not sunk, Mr. Wells? See, that's the problem, Spoon. If I had stayed up there on the higher bands, if somebody had complained to the local radio station, I would have been in trouble. Now, mind you, I am probably only transmitting at a couple of watts, if that, maybe a watt. Actually, probably not even that. Let's see. You know what? Let me see if I can hook up a test thing to it and find out how many amps we're drawing here. And that can tell me how many watts this thing is doing. Okay. Whoa. Staticky. Alright, so. Oh, you guys can't see that right now. Workbench camera. Hey. Okay, oh. Winamp can be paused at the moment. It doesn't need to continue to play. In fact, actually, it could probably go away for the moment. So, what I'm going to do is, let me get one of my other alligator clip wires here. We are going to clip that to here. And let me turn this down before I disconnect it so I don't like kill everybody here, because it's going to go static. Put that there. Put that there. Alright. Alright. We are back transmitting. And I'm not even pulling an amp. Okay. I'm pulling roughly 12 millivolts. Well, 11.5 millivolts at 11.5 milliamps at 5 volts. So let's do the math on that. I forgot, I have a dedicated calculator button. Alright, so 11.5 times 5. This is transmitting at roughly 57.5 milliwatts. I'm just over a half a watt. Or no, I'm not even a half a watt. I'm not even a quarter watt. Let me do this a different way. So milliamps. So it is actually, so we'll want to delete. It is 0.0 115 times 5. So yeah, I am transmitting at, how much of a watt is that? That's 0.05. That's like, it's like 1/5 of a watt. This signal, according to the thing, about a half a meter. It says launch distance 5 to 50 meters, but yeah, no, it's about a half a meter. A fifth of a watt. Yeah, I could see that going about a half a meter, but that's about as far as it's going to go. It's not going very far. It's probably not even getting out of my house, Spoon. The concrete walls of my house are probably blocking it. Maybe my neighbor, if he's tuned into the right frequency, could hear me, but no. But then again, the reason I bought this little kit is so I could hook it to my cell phone and have it in my car and just tune my car stereo to 88 megahertz and be able to listen. Mr. Wells, look up radio. 99.9% of it is in meters. You've got your 2 meter band, you've got your 4 meter band, you've got your 7 centimeter band, you've got, you know, need I continue? And everything, you know, the loss ratio of transmit power is calculated in dBs per meter. The only reason I'm spiking so high on my SDR is because the antenna for my SDR is sitting in my window and the transmitter is sitting on the desk. So literally the antennas are only about 2 feet apart. Which might also be why I know why I'm showing up so dirty. And actually, here's an interesting thing I've just noticed. You see that artifact right there? That one right there? That is a sub frequency of this. And if we expand the zoom, there's probably others. Oh, how do I expand the zoom? I forget how I... Oh, here's the zoom. Oh, I was already zoomed as far out as I could zoom. Maybe range? Oh no, that's contrast. That's for my little waterfall down there at the bottom. Range. Oh, that just affects the scale there. Okay. Ooh, look at the pretty colors. Yeah, well, this thing is definitely out of FCC regulations. Oh. So, if you're going to use this on a professional level, I would not suggest it because it is so far out of FCC regs for modern transmission devices that it's not even funny. You're taking up the bandwidth of 3 channels. So you see this lighter gray area, that should be the standard bandwidth of a channel in the United States. And I am all the way over here and all the way over here. Plus I've got noise up here and you can't see it, but there's probably more noise down here. Oh. As an amateur radio guy, oh. Although the echo effect's kind of cool that I've got going here. Oh, alrighty. WDR3. I am not sure what channel that is. I do know that right now this has been my favorite one. I'm gonna turn it down because I don't know what song they've got on.
Up forever.
A commercial, of course.
Even comes near the front door. Car. Wow. Turns out it's my car.
Yeah. 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 WDR3, I'm not familiar with that reference. Honestly, Spoon. Oh, okay. But at least I'm not transmitting too hot because I'll have to look that one up. But I am not sure, and it's probably outside the frequencies of the US. But anyways, so in conclusion to this device here, let me flip back to here. Okay. So it was a quick little kit to build. Only took about an hour to assemble, and then, you know, a little bit testing. It is, you saw that I could adjust the frequency pretty well. Honestly, I should have been using a plastic screwdriver instead of my metal one, because that core is graphite and it can shatter. And if it shatters, you're done. This transmitter will no longer work. But it's a nice kit. It went together easily. Again, I would not use it for professional transmitting because of how dirty it is. But if you're looking for just a little project to throw together and only use in your house, or in my case, in my case, I'm going to be using it for in my car. If my Bluetooth quits working like it has been doing, then I can plug this in. I'll have to come up with a case for it, but I'll plug this into like a USB port and have it, my phone power it, and have my phone plugged into the other end. But other than that, it is a nice and decent kit.